everyone, we're going to evaluate the given integral from over the interval z 0 to t. We're using integration by parts, and here's our formula we're going to use, but we have definite integrals here. So basically, let's figure out our u, v, and du, and we're going to let u equal sine of t minus s, and we'll let dv equal e to the s power, so du is just going to be negative cosine of t minus s ds, and v is just going to be e to the s again. All right, so we're going to start with our first integral here. We're going to have two actually, and using our formula, we're going to get e to the s power times sine of t minus s from 0 to 2 to t. Then you're going to get minus the integral 0 to t e to the s. There's going to be negative there. Cosine of t minus s. I knew this was going to happen. It's going to be a little small. So I'm going to put this negative, two negatives to make a positive, and squeeze this in here. So we have e to the s cosine of t minus s ds. All right. So I'm going to evaluate this first part here. When you evaluate that, you're going to get, let's see, plug in t first, so you get e t, and then sine of 0 minus e to the 0 sine of t plus our integral here. So I'm just going to call that plus our second integral. I'll just call it 1. If this one's 1, this one was our initial one. Okay? And so now let's take care of this one. So for this one, I'm looking at this, and it's kind of a little messy there, but we'll let u equal cosine of t minus s, and we're going to let dv equal es ds. All right, so the derivative of u is just going to be sine of t minus s ds, and then big V is just going to be e to the s, the antiderivative of this. So our interval for this one is just going to equal e to the s cosine of t minus s, and then you evaluate it from 0 to t minus the integral 0 to t sine of t minus s ds, which basically, when you look at this, I forgot to put e to the s here. When you look at this, this is back to where we started again. So this is back to our original interval. So let's evaluate this. I'll evaluate it on the next one. If you evaluate that, you're going to get e to the t power cosine of 0. And I'm going to always make that like that. 0 minus e to the 0 cosine of t. And then you have minus your original integral. Now, if we put everything together, we're going to get I, your integral equals sine of t. No, it's actually negative sine of t plus e to the t power minus cosine of t minus I. So let's add I to both sides. And that's going to give you 2I equals e to the t power minus cosine of t minus sine of t. Therefore, finally, if you divide everything by 2, you get I, or just multiply everything through by 1/2, and just write it like this. Just copy this down, cosine of t minus sine of t. And that's your final answer. Thank you. Have a nice day. Bye-bye.